All right, hey everyone, welcome back. So the final topic of this note packet, I believe, is this nested f-test. And so we're gonna set this up with a couple of different motivations, and this video should be fairly short and just kind of cover the motivation behind why we would want to do this test, and then we'll actually see the mechanics behind the test a little bit later. So the first motivation comes from our body fat example, and we're going to suppose that we have this population level regression model using weight, height, and abdomen as our predictors. Our response is still body fat percentage. What we've seen so far in terms of inference is we've seen a test to see if there's evidence that at least one of the predictors is associated with body fat percentage. And so the null hypothesis for this test was that all of the beta coefficients were equal to 0, except for the intercept. We've also seen a test to see if one of the predictors is associated with the response after accounting for the effects of all the other predictors. So maybe we want to know if weight is associated with body fat after accounting for the effects of height and abdomen. And so the null hypothesis for that test would just be that the slope coefficient for weight is equal to 0. What we haven't yet seen is, well, what if we wanted to kind of see if weight or height were associated with body fat percentage after accounting for the effects of abdomen? In other words, it's kind of like a test that's in between these two. So it's going to test more than one of these beta coefficients, but not all of them. The nested f-test would be able to address that purpose. And so in other words, it would be able to address the test of a null hypothesis of neither weight nor height is associated with body fat after accounting for the effects of abdomen. Versus the alternative that at least one of beta 1 and or beta 2 is not 0, corresponding to either weight or height or both. And then the same is associated with body fat after accounting for the effects of abdomen. All right, so that's kind of motivation number one. We might be interested in that particular test to see if either weight or height is associated with body fat after we account for the effects of the other predictors. The nested f-test will allow us to do that. I think an even more common motivation is the second one, where suppose that we have a predictor with more than two categories. For a predictor with just kind of k arbitrary number of categories, we decided that we would need k minus 1 indicator variables. Up to this point, we've only dealt with categorical variables or categorical predictors with two categories. We haven't yet seen a categorical predictor that has more than two. But what if the categorical predictor had 3 or 4 levels? Then how would we test for association? You might be able to kind of jump ahead a little bit and think that, okay, if our categorical predictor had 3 levels, then we'd have 2 indicator variables. And to test for association, we'd actually be testing both of those indicator variables at the same time, putting us back in this situation where we're testing multiple coefficients. If that idea doesn't yet make sense, definitely don't worry about it, because we'll see it directly with this next example that has a categorical predictor with 4 different levels, so we'll kind of see what that means for our hypothesis test.